Hey everybody, it's Ripley back again. This is probably one of the cooler sections. I like seeing kids work with this because they'll pull out their colored pencils and their crayons and revert back to like second grade, tongues out of their mouths while they're sketching these things. We're going to talk about systems of inequalities now. I love this one. So let's play with one. How about this guy? What if I said that x squared plus y squared equals 9? Oh, excuse me, is less than or equal to 9. And then how's about, I don't know, y is greater than 2x minus 1. Okay? What? Huh? Look at this. I got inequalities. What's going on here? Well, it's real simple. Watch how we deal with it. So cool. I love these as a kid too, so call me a weenie. Call me what you will. So I'm just going to sketch this. Let's call this a circle of radius 3, centered at the origin, horribly drawn. And let's go, 2x minus 1, so it's going to look kind of like this, right? So what do I have here? I have this right here is x squared plus y squared equals 9. And then this guy right here is 2x minus 1 equals y. All right, that looks like a plus. Can't draw real small. So how do I deal with the inequality portion? Well, just like we did before. Watch. Remember? Think about what it means to be less than all of the points on this circle. Now, remember back, it might be easier to deal with the line, right? Remember how what I would do is I would shade in a region that was greater than 2x minus 1. 2x minus, that's a 1 right there. Right? So where are the set of points where the y values are always greater than this line, 2x minus 1? Well, you just shade in above, right? Now, we got to be careful though, because this guy right here says greater than, which implies that the line itself is not part of the boundary. So what I got to do is I got to come through here and pop out and make it dotted, don't I? Whoops. Oh, come on. God bless America. All right, make it dotted because I'm greater than the line, not equal to the line. Now, a good question here is, where am I less than or equal to all of the points on a circle? Now, hopefully you were taught this back in Algebra 1 and Algebra 2. In an inequality situation, all that you got to do is pick a point and then determine whether or not that point satisfies the inequality. Let me change back to blue. I'll show you what I mean. All right, so let's pick some point that we know is above the line. Let's keep it simple. How about -1, 1? So if I want to check to see which seems to be about right there, I want to make sure that it's in the region defined by the inequality. Well, if I stick in -1, 1, let's see. I'm going to put 1 is greater than 2 times -1 minus 1, so 1 is greater than -3. Check. It works. We can use that exact same technique. Let me change colors. If I want to make sure that I know what I'm doing as far as defining a boundary line of something like a circle or an ellipse or a hyperbola, which can be kind of ugly. So what do I think? Do I think that if I'm going to shade less than or equal to the circle itself, is it going to be inside or is it going to be outside? Well, I don't know. My intuition says inside. So let's pick the point 1, 1, which clearly is not going to be there. Let's say it's there. Sorry about my cruddy drawing. 1, 1. So if I have 1, 1, and I'm going to test this thing, well, 1 squared plus 1 squared is less than or equal to 9. Well, last I checked, 2 is less than or equal to 9. So that has to be true of all of the points inside the circle because there's no other curve to help define that inequality. So the way we do it is we just shade in here. Now, where is the solution? It's anywhere, now this is where I get ugly, anywhere that they overlap. So the solution is actually all of those points right there. It's also on the boundary line of the circle up here. You see why? Because these points are both less than or equal to 9 and they're above the line. Ooh, that's good fun. All right, let's try another one. Just do one more. I'm not going to beat on you about this guy. These are always kind of fun. How about this? It's also really important that you have good graphical understanding of these guys. Otherwise, you're definitely going to be lost. It can get pretty tricky. How about y equals negative x plus 4? And, I don't want it to be, let's make it greater than or equal to. And then y is, no, let's make this more fun than that. Let's go y squared over 4 plus, you guys are going to hate me now. Let's go minus. Sorry. Minus x squared over 9 equals 1. Oof. Well, don't want to do equal to. Let's make it less than or equal to. Now we got to identify what we're looking at. Well, that's a line. I'm hoping that you can see that. Now what's this guy? If I didn't have these inequalities in here, what would this be? Well, remember y squared over a squared minus x squared over b squared equals 1. What was that again? It's hyperbola. Hyperbola. Now, if you're not good with conic sections, this section's going to punish you a little bit, but we've spent some time in conic sections, so hopefully you're doing okay with those things now. So first things first, negative x plus 4, I'm just going to sketch this thing. Right there. And then, that's bad. That's just terrible, sorry. Why do I suck so bad at sketching sometimes? It's the software. All right. And then how about this? Let's see, y squared, so it's y squared on top. I remember this. So I build a box, right? So I go up to, remember how this works? Up to, down to, left 3, 1, 2, right 3, and then I build this guy right here. And does it open up or down? It opens up, so I end up with this guy, right here, and this guy right here. That's my hyperbola. Now, let's start shading and see what happens. Well, I'm greater than or equal to, so where am I going to end up? I'm going to end up here, right? Greater than. Same question. So I've got y squared over 4 minus x squared over 9 is less than or equal to 1. Where am I going to shade? Well, I'm either going to shade all of this kind of hourglass shape in here, or I'm going to shade inside of these sort of semi-parabolic looking. Remember, they're not parabolas because parabolas don't have asymptotes. All right? So what do? We'll pick a point. Let's do in red. We're going to pick a point. How about 0, 0? 0, 0. That seems to be an easy one. Is 0 squared over 4 minus 0 squared over 9 equal to 1? Or, excuse me, less than or equal to 1? Well, yeah, last I checked, 0 is less than or equal to 1. Check. So guess what? I'm going to shade all of this right here, and then wherever they cross over is my solution. So, wow. So I'm going to have all of this stuff over here in my solution. All right, enough torture of you guys. Hope you enjoyed it. Bring your crayons, bring your colored pencils, bring your colored pens. This is always a fun one, especially for kids that like colors. And I'm a kid that likes color. So have a really good day. Thanks for your time and attention. I'll see you in class tomorrow.